by the independent and dependent variables, right? The hypothesis is that reproductive isolation increases with geographic distance, right, between dusky salamander populations. Our independent variable, right, is the geographic distance between populations, and our dependent variable is the reproductive isolation values for pairs, right, between salamander populations. We good? That's the first one's always easy. Okay, and what did they do, right? Explain why the researchers used 4 mating combinations, right? They set up 4 mating combinations to compare the proportion of successful matings within populations, right? To the proportion of successful matings between populations, right? So we're talking about within populations. It's, what do they call it? A with A, right? Versus A with B, right? Within, A with A, between, A with B. Good? 2, right? Calculate the value of the reproductive isolation index. So they define this reproductive isolation index, right, in the data from the experiment section. The proportion of successful matings for each mating combination was measured with 100% success equals 1 and no success equals 0, right? So, if, right, all of the matings within a population were successful, within, right, but none of the matings between populations were successful. So that would be, right, and then it tells you here, right, that the reproductive isolation value is the sum of the proportion of successful matings for each type within populations minus the sum between populations, right? So for A, when we have, right, all of the matings within were successful, so we have 2, right? And then we're going to subtract 0 because none of the matings between the populations were successful. And then for B, it's the opposite situation, right? So we have, oh wait, sorry, it's not the opposite, my bad. Right, the salamanders are equally successful in mating with members of their own population, so within, and members of another, so between. So in both cases, it would be 2. So in that case, right, our the value of our reproductive isolation index would be 0. Right, here, bless out, yes?
If you go to number 1 for like 5 seconds.
Yeah. That number 1 or the other one?
This is it.
5 seconds. 4. Bless Allie's heart. She made the scatter plot. I love y'all. I would never have done this shit for you. Bless her. Bless her. Right? She actually made the scatter plot. What do we see with this, right? Like I don't think she had, no. Like we could draw a best fit just easily, right? We can all see the trend here. Yeah? Right? So when we graph these, we see that as geographic distance increases, so does the degree of reproductive isolation. All right? Is there other stuff here? Nope, that's 3, right? And then for 4, we can definitely see, right? Interpret your graph by explaining what's the relationship. We can definitely see that reproductive isolation is more likely to occur as populations become separated by greater distances, right? And then for part B, right? 4B was hypothesizing the possible cause of this relationship. So this was her, I think she did like multiple, yeah. She did multiple choice for this, which I thought was cute. So which hypothesis suggests a possible cause of the relationship, right? Geographically separated populations of dusky salamanders gradually diverge, and the divergence increases with geographic distance. So if we look at the wrong answers, right, like these are just different, this is knowing your concepts, right? Like small populations diverge due to genetic drift? No. Right? The founder effect? No. No, no, no. Right? Sympatric populations of dusky salamanders gradually diverge because they exploit different food sources. No, this is geographic, right? Okay. Okay, so that was 22. Do we want to do 21? Should we just go backwards, I guess? That's kind of a weird way to do it. There we go. Okay, so page 406. Woo! Right, already one. This is the one where I just can't stand up and write out math for you guys. So do we need help solving this part?
No.
Setting it up.
No, it's fine.
Because I will call one of you up to write it out. I know someone in here can do it.
Because the formula is just 2 times, right?